In this video, we'll talk about the slope of a line, and this is from Chapter 3, Section 3. Slope is a measure of how steeply a line rises or falls as it moves left to right. We use the letter M to represent slope. More specifically, M, or the slope, is equal to how much rise a line has divided by run, or how much it goes up and down in relation to how far it goes left and right. Let's start by looking at two lines. In some ways, these two lines are similar, and in others, they are different. Both lines, as we move from left to right, go up. That is, they both have a positive slope. But the second one, the blue one, is steeper than the green one. That means that we have a greater positive slope with the second one and a lesser positive slope with the first one. Let's look at 2 points on the first graph. To get from one point to the other, we need to do a certain amount of rise and a certain amount of run. And that ratio of rise over run is the slope of that line. When we talk about rise, we're going up and down. Another way to notate that is with a delta y, which is read change in y. When we talk about run, we're moving left and right, and it's how much we change in the x direction. We can notate that with a delta x. So another way to write slope is m equals rise over run, which is equal to the change in y value divided by the change in x value. As we move from left to right, we go up. So our change in y value is a positive number. And we go to the right, so our change in x value is also a positive number. A positive over a positive is a positive, so we have a positive slope. Let's look at two more lines. Again, these two lines have some qualities in common and others that are different. As we move from left to right, both of these lines go down, which means they both have a negative slope. But the first one is steeper than the second one, and that's how they're different. Let's look at a couple of points on this second picture. Now as we move from left and right, our change in y, or our rise, goes down, while our run still goes to the right in the positive direction. That is, our delta y, or change in y value, or rise, is a negative number, while our change in x, or delta x, or run, is a positive number. In this case, when we look at the equation for slope, we have a negative divided by a positive, which is a negative slope. Let's take a look at example 1. In example 1, we're asked to find the slope of the line that passes through two given points. We'll look at part A and part B. In part A, we first have the point -2, 5. Starting from 0, 0, we need to move to the left 2 units and up 5 units. To plot the point 4, -7, we need to move 4 units to the right and 7 units down. Now we can sketch our line. Looking at these 2 points, let's talk about how much rise and how much run happens to get from one point to the other. If we start at -2, 5, the amount of rise we would have to do is moving down to a height of -7. Then we have to move to the right to represent the run. To go from a height of +5 down to -7, we have to move in the negative direction 12 units. That is, our change in y value is -12. To go from an x value of -2 over to +4, that's a change in the positive direction of +6. Now we can use these two numbers to calculate our slope. -12 over +6 is -2. So the slope of the line between these 2 points is -2. Now let's look at B. First we plot the points -3, -4, and +1, +10. And now we can sketch the line between the 2 points. To get from -3, -4 to +1, +10 requires that we go up 14 units. That is, our change in y value is 14. To go from an x value of -3 to +1 is a change in the positive direction of 4. So delta y is +14 and delta x is +4. That means that the slope is 14 over 4, which simplifies to 7/2. Let's now generalize what we've been doing as a slope formula. If we have a line that passes through 2 points, we'll call them x1, y1 and x2, y2. We can calculate the slope of this line using the following formula. We already know that the slope is equal to rise over run. We also know that that is equivalent to the change in y value divided by the change in x value. But if we have two specific points, we can write the change in y value as y2 minus y1, and the change in x value as x2 minus x1. Let me show you what I mean. Here's our 2 points, x1, y1 and x2, y2 on a line. Let's think about how we would calculate the change in y value and the change in x value between these 2 points. To talk about the change in y value, we have to go from a height of y1 up to a height of y2. Think about what that distance is. This is the height of y2 minus y1. The difference between those values is our change in y value. To get change in x, we need to go to the right over from x1 to x2. And we can represent that change by taking x2 and subtracting x1. And that will give us the difference between those two values, or the distance between those two values. In other words, delta y can be calculated using y2 minus y1. And delta x can be calculated using x2 minus x1. Substituting those into our slope equation that we had before gives us this slope formula. Let's practice using it in example 2. In example 2, we're going to use the slope formula to find the slope of the line that passes through 2 given points. Let's look at part C. In C, we first have the point 1, 2. Let's refer to this point as our x1, y1. Our second point is the point 5, 14. Let's refer to this point as x2, y2. It's important to note that we could totally switch this around and decide that 5, 14 is x1, y1 and 1, 2 is x2, y2. And we would still get the same result. What's important here is that you keep the order the same. Don't put x1 with y2 or x2 with y1. Now we can substitute these values into our slope formula. With y2 equal to 14 and y1 equal to 2, we have 14 minus 2 in the numerator. With x2 equal to 5 and x1 equal to 1, we have 5 minus 1 in the denominator. Simplifying, we have 14 minus 2, or 12, over 5 minus 1, which is 4. 12 divided by 4 is 3, so we know that the slope of the line between these 2 points is positive 3. Let's skip to F. We will follow the same process here. This time we have x1 as -2 and y1 as -3. We have x2 as +2 and y2 as -9. Let's substitute those into our slope formula. Substituting, we have y2 is -9, y1 is -3. x2 is +2, and x1 is -2. Notice how important these parentheses are so that we make sure to account for those negatives. In the numerator, this is -9 minus a -3. 2 negatives make a positive, so it's -9 plus 3. In the denominator, we have 2 minus -2. 2 negatives again make a positive, so this is 2 plus 2. -9 and a +3 is a -6. 2 plus 2 is 4. Now we just need to simplify. Dividing these both by 2, we have -3/2. So the slope of the line between these 2 points is -3/2. That is, as we move from left to right on this line, we're going to go down 3 units for every 2 units of run to the right. Let's look at 2 special cases. First, take a look at the horizontal line, and let's just pick 2 random points on it. I chose the points 2, 6, and 7, 6. Let's calculate the slope of this line using these 2 points. Substituting the values from our points, we have y2 as 6, and y1 is also 6. x2 is 7, and x1 is 2. Notice that with 6 minus 6 in the numerator, this becomes 0 over 5. 0 over 5 is just 0. That is, horizontal lines have a slope of 0. If we think about this in terms of rise over run, moving from left to right, we don't have any rise. We stay flat, no matter how far we run. That is, we have 0 rise for any amount of run, which is always a slope of 0. Recall that the equation of a horizontal line is y equals some real number b. We also know that it has a y-intercept of 0b. In this case, that would be y equals 6 with a y-intercept of 0, 6. We can now add to what we know about horizontal lines. They have a slope of 0. Now let's talk about vertical lines. Again, I'll just choose 2 points. This time I have -3, +2, and -3, 5. Let's calculate the slope between these 2 points. Substituting, we have y2 is 5, y1 is 2. x2 is -3, and y2 is also -3. Simplifying, I have 5 minus 2, or 3, in the numerator, but I have -3 minus a -3, which is -3 plus 3 in the denominator. This simplifies to 3 over 0, which we know is undefined. We can never divide by 0. Let's talk about this in terms of rise over run. Looking at this line, there's never any run. We don't move left or right, no matter how much rise we have. So the slope of a vertical line will always be undefined based on the definition of rise over run. Let's summarize what we know so far about vertical lines. We know that vertical lines have equations that look like x equal to some real number a. In this case, this one would be x equal to -3. They have x-intercepts at a, 0. In this case, it would be -3, 0. And now we know that the slope is undefined. I like to abbreviate undefined with a capital UND. Let's move on to example 3. In example 3, we're asked to find the slope if it exists. Looking at part A, we have x equals 5. We notice right away that this is x equal to some real number. In other words, this is a vertical line. More specifically, it's the vertical line with an x-intercept of 5. We just learned that vertical lines have undefined slopes. So the slope of this line is undefined. Let's look at D. In D, we have y equals 6. We know that equations that look like y equal to some real number are always horizontal lines. So this, of course, is a horizontal line. More specifically, this is the horizontal line with a y-intercept of 6. We just learned that horizontal lines have a slope of 0. So the slope of this line equals 0. Now let's talk a little bit more about equations of lines. In this section, we'll talk about 2 different forms of the equation of a line. The first one we have is standard form, where we have the x term and the y term on the left and the constant term on the right. The only requirement is that we don't have both a and b equal to 0. The second one we call the slope-intercept form of a line, and that's when we solve the equation for y and move the x term and the constant term over to the right. There's a reason why this is called the slope-intercept form of a line. Remember that when we want to find a y-intercept, we set x equal to 0. If we do that here, we end up with y equal to m times 0 plus b, or y equals b. That is, when we have the equation of a line in the form of y equals mx plus b, b tells us where the y-intercept is. Y-intercept is 0, b. So this portion of the equation tells us the y-intercept. It also makes easily available the slope of the line. M is the coefficient of the x term. If you want to see why this is true, I'll show you real quick. Suppose we have the point x1, y1. If they're points on this line, that would mean that y1 is equal to m times x1 plus b. If we also have a point x2, y2 on this line, then y2 is necessarily m times x2 plus b. Let's calculate the slope between these 2 points. We'll start out with y2 minus y1 over x2 minus x1. Let's substitute for y1 and y2 what we just wrote above. Distributing that negative in the numerator and then simplifying, you'll notice that the b's will cancel out and we're left with mx2 minus mx1 over x2 minus x1. At this point, we can factor out the m, which is doing the distributive property in reverse. And once we're done simplifying, we just have m. That is, the slope between any 2 points on this line is m. So having this in slope-intercept form quickly gives us the slope and the y-intercept. Let's take a look at example 4. In example 4, we're given equations and we're asked to find the slope and the y-intercept just by looking at the equations themselves. In part A, this is given to us in slope-intercept form. We can identify pretty quickly that m is equal to 5 over 2. That's our slope. We can also see that b is equal to negative 6. That is, our y-intercept is the point 0, negative 6. Let's look at D. This time, our equation is given to us in standard form. We can switch this by just solving for y. We can subtract 6x from both sides, and we can divide both sides by negative 3. Be careful when you divide the right side by negative 3. Make sure that each term gets divided by negative 3. We have negative 6x over negative 3 minus 21 over negative 3. This leaves us with y equal to 2x plus 7. Now that we have this in slope-intercept form, we can quickly see that the slope is 2 and the y-intercept is 0, 7. In example 5, we'll do the same process but in reverse. Here in example 5, we are given the slope and the y-intercept, and we are asked to write the equation of the line. A line in slope-intercept form is y equals mx plus b. We're given that our slope is 1/2. So we can substitute 1/2 for m. The y portion of our y-intercept is negative 4 over 7. So that tells us that our b is negative 4 over 7. And now we have the equation of our line. Y equals 1/2 x minus 4 over 7. Let's head on over to example 6 and start to graph these. In part B, we have the equation y equals negative 3x minus 5. We know that this coefficient with the x term is the slope, so our slope is negative 3. We also know that b, or the constant term, is the y portion of our y-intercept. So with b equal to negative 5, we know we have a y-intercept of 0, negative 5. Let's start by plotting the point 0, negative 5. Now let's use our slope to tell us which direction and how steep this line should be. We have a slope of negative 3. We could think of this as negative 3 over 1. This way we can look at it as rise over run. Starting with the y-intercept, let's do a rise of negative 3, which is down 3 units, and a run of 1. And we will have a second point. Down 3 and right 1. With those 2 points, we can sketch our line. We can also continue the pattern to help us sketch it by hand. And now we have the graph of the line. Here in part C, we have the equation y equals negative 2/3 plus 4. We know that this means that our slope, m, is equal to negative 2/3. We also know that with our constant term b equal to 4, this means that we have a y-intercept of 0, 4. Let's plot that y-intercept. We can now use our slope to plot some more points. With our slope equal to negative 2/3, we could rewrite this as negative 2 over positive 3 or positive 2 over negative 3. Either way will work just fine. I'll consider this as rise of negative 2 and run of positive 3. That means for every 2 units down, I want to go to the right 3 units. So I have a rise of negative 2 and a run of positive 3. Having a second point is enough to sketch the graph, but having some more is sometimes helpful too. And now we sketch our line. We have one more example before we're done. In example 7, we are asked to interpret the slope and the y-intercept. In other words, given a linear equation, we want to figure out what the slope means and what the y-intercept means. In part A, we have the number of women, which is the y value, accepted to medical school in a given year can be approximated by the equation y equals 218x plus 7,485, where x is the number of years after 1997. Let's first talk about the slope. Slope is change in y over change in x. In this case, x is years since 1997, and y is number of women. We know that the slope is 218. We could also write that as 218 over 1. Change in y is the change in number of women. Change in x is a change in years. In other words, in average, there's a positive change of 218 women in medical school per year. Now let's talk about the y-intercept. The y-intercept in this case is the point 0, 7,485. With an x value of 0, that's 0 years since 1997. In other words, the year 1997. And if y is the number of women accepted to medical school, that tells us that 7,485 women were accepted to medical school in the year 1997. And this will conclude this lecture video.